All right, let's keep on our Ziglings adventure. You can ignore that. I was doing some stuff. All right. So we had just finished pointers, which I forgot most of it, but I think it's just like normal pointers, right? Yeah, whatever. We'll figure it out as we go. Optionals. Sometimes you know that a variable might hold a value or it might not. Zig has a neat way of expressing this idea called optionals, question mark in front of the type. Now, foo can store U32 or null, or a value not existing, foo equal null. You can scream for you. The optional value is non-null type. You can guarantee that it isn't null. One way to do this is to threaten it with the or else statement. Please threaten the result so that is either the integer value from deep thought or else 42, right? Yeah. Last one, options are a lot like error union types, which can either hold a value or an error. Likewise, the or else statement is like the catch statement used to unwrap a value or supply a default value. Okay. So we can just run this. I think this is like a Hitchhiker's Guide to the Galaxy reference. I've never read / watched it. Now that we have optional types, we can apply them to structs. The last time we checked in with our elephants, we had to link all three of them together in a circle. So the last tail linked to the first elephant. This is because we had no concept of a tail that didn't point to another elephant. We can introduce the handy period question mark shortcut. Or else unreachable. Okay. Check out where we use the shortcut below. Change control flow based on if an optional value exists. Tail needs something. What do we want to do here? So like what we want to make this optional? I thought pointers could be null. Maybe not. Yeah, they never mentioned null here, so that's kind of weird. And then points to the next. A points to B, B points to C. On comment and see what happens. Okay, let's see what happens when we uncomment these. Oh, what's this? Or else. No? No. No. This is what? Like this? No. We should stop once we encounter a tail that does not point to another element. What can we put here? Want something similar to what? I don't know what this is, what they want. Oh, I think it's or else break, right? I think that's what we want. Or else break if it's no. Yeah, okay. Now let's run this. What does this panics to attempt to use no value. Okay. Okay, so that worked. Link elephant. Or else unreachable. Okay, I see. I get it. I get it now. Okay. I don't like that. So E1 or else unreachable, but then you can grab the value of that and call tail on it. Yeah, I don't like that at all. But our methods help. Evil alien creatures have hidden eggs all over the earth and they're starting to hatch. Before you jump into battle, you'll need to know 3 things. You can attach functions to structs and other type definitions. Okay. Function as a member of structure's namespace within that struct. Okay. Makes sense. Neat feature of these functions is that if their first argument is an instance of the struct or a pointer to one, then we can use the instance as the namespace instead of the type. So this is like Python, right? Python does this. I don't like this. I get it. I don't like it though. Notice that the name of the parameter doesn't matter. Some use self, others use lowercase version of type name, but feel free to use whatever is most appropriate. Hideous aliens shrunk. We hate this method. Zap those aliens. Number of damage. Zap this alien. And this thing is health. Oh, self.damage. Alien health minus equal. If damage is bigger than alien health. Okay, so take it to 0 or apply the damage. Hatch a bunch of aliens with. We've been given a heat ray weapon that does 7 damage. We'll keep checking to see if we've killed all the aliens yet. Okay. Heat ray dot zap alien. Like that, right? I think that's it. Yay, Earth is saved. Good. Easy enough. Now that we've seen how our method, let's see if we can help our elephants out a bit more with some elephant methods. Get tail. Has tail. Visit. Print. Main. This links the elephant so that each tail points to the next. Okay. Visit the elephants. Visits all the elephants. 1. This gets the next elephant or stops. I completely forgot this. E-tail or else. Okay. Tail or else. Like this. Visit all the elephants once, starting with the first element, following the tails to the next elephant. And then if there's a tail, I guess this should be get tail. Get tail or else break. Something like that. Is that right? No. What the fuck did I do? Expected optional type. Get tail returns an elephant. ABC. Okay, yeah. If you have an optional, why the hell would you do it this way? I guess that's why I'm confused a little bit. Yeah, so enums have methods too, which is interesting because there have been times in C++ where I really wished I could put some conversion functions inside an enum. Right, quiz. Trunks and tails are handy things from holding hands. Can we implement trunks? Why is function get trunk self elephant elephant return self dot function get has trunk elephant. I'm a little bit low energy today, guys. It's not a return self dot trunk not equal null. All right, and visited print whatever. Link the elephants so that each tail points to the next. C points to B, B points to A. Okay. Follow the trunks. I think that's it. What did I do? Oops. Oopsies. Yeah, there we go. There we go. And that goes backwards. All right. No value. We live on a planet. I don't care about your poetry. Zig has at least 4 ways of expressing no value. Undefined should not be thought of as a value, but as a way of telling the compiler that you are not assigning a value yet. Any type may be set to undefined, but attempting to read or use that value is always a mistake. Null. Null primitive is a value that means no value. This is typically used within optional types. When foo equals null, that's not a value of type U8. It means there is no value of type UA in foo at all. Error. Very similar to nulls. They are a value, but they usually indicate that the real value you are looking for does not exist. Instead, you have an error. The example error union type of my error U8 means that foo either holds a U8 value or an error. There is no value. So can you do an error with an optional U8 inside? So if there's no error, but there's no value, it means that you've... void is a type, not a value. It is the most popular of the 0-bit types. They has all of these ways of expressing different values of no value. They each serve a different purpose. Briefly, no value yet. Explicit value of no value. There's no value because something went wrong. There will never be a value there. Okay. All right. So this one, first line is undefined. This is... I'll say undefined still. We need the... Okay, print second line. Print second line is an optional. It's null. This is a void. I didn't do that out loud. I figure you guys can keep up. This looks like it worked out. So undefined, no value yet. Undefined because there's no value yet. Even though it holds an error, it's still undefined. And then this one here is a void because it doesn't return anything. And then this is null because it's an optional. Values. If you thought the last exercise was a deep dive, hold on to your hat because we're about to descend into the computer's molten core. Okay, I don't care about this. Now we can look at some familiars. Import adds the imported code to your own. In this case, code from the standard library is added to your program and compiled with it. All of this will be loaded into RAM when it runs. Oh, and that thing that we named const standard, that's a struct. Remember our old RPG character struct? A struct is really just a very convenient way to deal with memory. These fields go a particular size and add them together and you have the size of the struct as a whole. Character called the narrator, that is constant, immutable instance of character struct. It is stored in your program as data. Like the construction code, it is loaded into RAM when a program runs. The relative location of this data in memory is hard-coded and neither the address nor the value changes. The global wizard character is very similar. The address for this data won't change, but data itself can, since it's a variable, not a constant. A function is instruction code at a particular address. Function parameters in Zig are always immutable. Makes sense. They are stored in the stack. Stack is type of data. I don't want to explain the stack is. CPU has special support for adding and removing things from the stack, so it is an extremely efficient place for memory storage. Also, when a function executes, the input arguments are often loaded into the beating heart of the CPU itself in registers. Our main function here has no input parameters, but it will have a stack entry called a frame. I'm just going to take a moment here and say might just go to quiz 7 today. Yeah, we're about quiz 7, and then call it. Here, the glorp character will be allocated on the stack because each instance of glorp is mutable and therefore unique to the invocation of this function. The reward XP value is interesting. It's an immutable value, so even though it's local, it can be put in global data and shared between all invocations. But being such a small value, it may also simply be inlined as a literal value in your instruction code where it is used. It's up to the compiler. Now let's circle back around to that standard struct we imported at the top. Since it's just a regular Zig value, once it's imported, we can also assign new names for its fields and declarations. Debug refers to another struct, and print is a public function namespace within that struct. Let's assign a standard debug print function to a constant named print so that we can use this new name later. Like this. Now let's look at assigning and pointing values in Zig. We'll try 3 different ways of making a new name to access our glorp character and change one of its values. Glorp access 1 is incorrectly named. We ask Zig to set aside memory for another character struct, so when we assign glorp to glorp access 1 here, we're actually assigning all of the fields to make a copy. Now we have 2 separate characters. You don't need to fix this, but notice what gets printed in your program output for this is compared to the other 2 assignments below. Okay. Note, if we tried to do this with const character instead of our chain of gold field, would give us a compiler error. Yes. Glorp access 2 will do what we want. It points to the original glorp's address. Also remember that we get one implicit dereference with struct field. So accessing the gold field from glorp access 2 looks just like accessing it from glorp itself. So no arrow functions, arrow operators, I mean. Glorp access 3 is interesting. It's also a pointer, but it's a constant. Won't that disallow changing the gold value? No. As you may recall from our earlier pointer experiments, a constant pointer can't change what it's pointing at, but the value inside can still be mutable, so we can change it. If we tried to do this with const character pointer, that would not work, and we'd get a compiler error because the value becomes immutable. Okay. So here, what it's saying, if we do this, it's going to give a compiler error. I'm going to keep that there. Moving along, when arguments are passed to a function, they are always passed as constants within the function, regardless of how they were declared in the calling function. Error arg is const. Knowing this, see if you can make level up work as expected. It should add the specified amount to the supplied character's experience point. Right? I imagine like this. And there's more. Data segments allocated at compile time and a stack allocated at runtime are the only places where program data can be stored in memory. They're just most efficient. Sometimes we don't know how much memory it will need although there is a limit to the size of stack memory allocated to programs. For the occasion, we have the heap. You can use as much heap memory as you like, but it's much less efficient to manage. Okay. Interesting. This is all very interesting stuff, but let's hit the play button. It should give me an error. Cannot assign a constant. That's exactly what I expected. Delete that. Try running that again. True. Before, after. Reward XP. 200. Yep. Perfect. False, true, true. Good. All right. That makes all sense. This is very simple stuff. Easy to follow if coming from C++. Slices. We've seen that passing arrays around can be awkward. Perhaps you remember a particularly horrendous function definition from quiz 3. This function can only take arrays that are exactly 4 items long. Sorry. That's the trouble with arrays. Their size is part of the data type and must be hard-coded into every usage of that type. This digits array is 10 U8 forever and ever. Thankfully, Zig has slices, which let you dynamically point to a start item and provide a length. Here are slices of our digit array. 0, 1, 1 item, 3, 2. This is start and end. It's not providing a length. Yeah. This is a start and end index. All right. Please put the first 4 cards in hand 1 and the rest in hand 2. So 0, 4, is it 3 dots? 2 dots. 0, 4, like this. Well, you should probably do it like that. Please with 4 cards, blah, blah. Please lend this function a hand, a U8 slice hand, that is. Yeah, that's what I figured it would be. So U8 slice. There we go. Print hand. Slices stores a pointer to the first item in length. Okay, so yeah, obviously. Ace 4, King 8. 5, 2, Queen Jack. Easy peasy, lemon squeezy. Slices 2. You are perhaps tempted to try slices on strings. They're an array of. Slices on strings work great. There's just one catch. Don't forget that Zig string literals are immutable. Excuse me. So we need to change the type of slice from U8 to const U8. So this is our string. Okay. Doesn't want me to do anything here, it looks like. It looks like it's just... What? Oh. Gonna make me do this 6 times. This is just annoying. Const. Are you good now? Cool. Four. Great. Justice. Okay. All right, many pointers. You can also make pointers to multiple items without using a slice. The difference between foo slice and foo pointer is that the slice has a known length. The pointer doesn't. It is up to you to keep track of the number of U8s foo pointer points to. Take a good look at the array type to which we're coercing Zen12 string. Okay, it would also have been valid to coerce to a slice const U8 to a many item pointer. Okay, it acts as Zen many pointer just like an array or slice as long as you keep track of the length yourself. A string in Zig is a pointer to an array of const U8 values or a slice. So we could treat a many item pointer of const U8 as a string as long as we can convert it to a slice. We do know the length. Please fix this line so the print statement below it can print. What is this? 21? No. I'm actually confused here. This makes no sense to me. Take a good look at the array type to which we're coercing. So this is, okay. Foo pointer 0 to 4. Okay. So it would be here 0 to 21. That what we want? Memory is a resource. And if I do 22, that worked. What if I do this? This will give me an error. If I do 100 and 99. I'm just curious what happens here. Online memory access. Because this is 21. I'm surprised that, well, I guess 22 would work and 23 wouldn't, right? Online memory access, yeah. That's funny. Okay, so if I do 21 and play that again, no period, oops, what the Zig experience in C-Line is not amazing. Memory's resource, still a period. Oh, it gave me a space before. 22 gave me a space. Interesting. Anyways. All of these pointer types starting to get confusing. Pointer to one U8, two U8s, pointer to an unknown number of U8s, pointer to an unknown number of immutable U8s. This is easy. Pointer to an array of two U8s. Pointer to a mutable array of two U8s. Yeah, that makes sense. Slice of U8s, slice of immutable U8s. Okay. This all makes sense so far. Union. Union lets you store different types and sizes of data at the same memory address. How is this possible? The compiler sets aside enough memory for the largest thing you might want to store. An instance foo always takes up U64 space in memory, even if you're currently storing U8. Looks just like a struct, but a foo can only hold a small or medium or large value. Once a field becomes active, the other inactive fields cannot be accessed. To change active fields, assign a whole new instance. Foo dot small equal 5. Okay. Okay. Unions can save space in memory because they let you reuse a space in memory. They also provide a sort of primitive polymorphism. Here, foobar can take a foo no matter what size of unsigned integer it holds. Okay, that makes sense. But how does foobar know which field is active? Zig has a neat way of keeping track, but for now, we'll just have to do it manually. See if we can get it working. We've just started writing simple ecosystem simulation, insects printed by bees or ants, whatever. Flowers visited, still alive. That's a union. Since we need to specify a type of insect, we'll use an enum. Remember those. Ant or bee. We'll just make one bee and one ant to test them out. Ant or bee. What is it? Ant or bee. Yeah, that's it. I think that's it. Cool. Unions 2. Let's see. It's really quite inconvenient having to manually keep track of the active field in our union. Tagged union, which will allow us to store an enum value within our union representing which field is active. Tagged union. Oh, okay, I like tagged unions. Now we can use a switch directly on the union to act on the active field. Okay. Foo tag enum. Still alive. Print insect. Could it really be as simple as just passing the union? I'm pretty sure it is. And B switch B p dot insect. Yeah. Did you remind you of option values and errors? Option values are basically null unions, and errors use error union types. Now we can add our own unions to the mix to handle whatever situation we might encounter. Cool. Let's play this. This should work. No problem. Good. All right. So, answer live true. B visit 16. Okay. Union 3. With tagged unions, it gets even better. If you don't have a need for a separate enum, you can just define an inferred enum with your union all in one place. Just use the enum keyword. Oh my. Oh, that's so nice. I was wondering. Okay. Now we'll change inside here. We'll just do enum. And I think the rest is fine. Inferred enums are neat, representing the tip of the iceberg in the relationship between enums and unions. You can actually coerce a union to an enum, which gives you the active field from the union as an enum. What's even wilder is that you can coerce an enum to a union, but don't get too excited. That only works when the union type is one of those weird 0-bit types like void. Tagged unions, as with most ideas in computer science, have a long history going back to 1960s. However, they're only recently becoming mainstream, particularly in system-level programming language. You might have also seen them called variants, subtypes, or even enums. All right, quiz. We've absorbed a lot of information about the variations of types we can use in Zig. Roughly in order we have, okay, I'm not going to read all these again. Values of any of the above types can be assigned as var or const to disallow changes. Yes, we can also make error unions or optional types from any of the above. Maybe we can help out a local hermit. He made a little Zig program to help him plan his trip through the woods, but has some mistakes. You do not have to read and understand every bit of this program. This is a very big example. Feel free to skim through it and just focus on the few parts that are actually broken. Yeah, this is very big. I'm just going to hit play. And let's just, this is a big example. Yeesh. Path. By the way, if you're following seems like a lot to use manually, you're right. One of the killer features is letting you write code that runs the compile time to automate repetitive code, much like macros, but we haven't learned how to do that yet. Path to from distance. Yes. Once we plot the best course through the woods, we'll make a trip out of it. A trip is a series of places connected by paths. We use a trip item. Okay. P doesn't exist. Place. I imagine this is self. Self is a trip item. Place, no. How to capture union values in a switch statement. Please capture each value as P. Oh. Dang it. How do we do this? Like this. Okay. P. So what is this? P. Oops. Like that? Yes. Okay. The Hermit's notebook where all the magic happens. Notebook entry. To-do list. Okay, cool. Notebook. Remember the array repetition operator is no mere novelty. It's also a great way to assign multiple items in an array without having to list them one by one. Here we use it to initialize an array with null values. Okay. Next, I'm going to keep track where we are. To-do list. Want to find an entry by place. If one is not found, get entry. Here's where the hermit got stuck. We need to return an optional pointer to a notebook entry. What we have with entry is the opposite, a pointer to an optional Optional pointer. Okay. Oof. Try to make your answer this long. To get one from the other, we need to dereference entry with like this and get the non-null value from the optional with this and return the address of that. The if statement provides some clues about how the dereference and optional value unwrapping look together. Remember, you return the address. God, Jesus. Let's see the notebook. Where's the notebook entry? It's a struct. Okay. This is a pointer, optional pointer, optional pointer. Where is it? Stuck. Okay. Get one we need to dereference entry with. Get. Try to make your answer this long. What? No. This. Here. Let's just. Where's the play button? Where's the play button on this fucker? Here it is. Let's. Okay. Expected type found pointer. So we found a pointer. Okay. So we got a pointer to an optional instead of an optional pointer. So I need an optional pointer. Like, I want to say else null here. Let's just see what that tells me. No. Found expected type, found pointer to still the same thing. Okay, let's look back at these optionals and see if it gives me an idea. Ooh, where else too? Where's my quiz? Where's my quiz? Oh, I'm sure this is dead ass simple. Expected optional pointer. I got pointer to an optional. So place is a optional pointer, is a pointer. So how do I make this an optional? How do I make it an optional is my question. There's gotta be a way of doing it, right? Optional pointer. First element, or else break. This is not it. This is not it. Dereference entry. Do this. Now what does this look like? Oh, dang it. Good thing I decided to end here. Found. Still a pointer to an optional. Quiz 7. This what I want? Fix it up. Found. I don't know how to make it. This is the correct length, it looks like, but expected type optional to this, but found pointer to optional. Why? I'm having issues trying to figure out how to. Let's see. Deep thought result. Return null. That doesn't help. Can I do this? No. Okay, let's see what happens if let's just do this. Let's return null. Fix everything else. Request never. Get entry. Yeah, this is okay. So this is something about null. I'm gonna use good old chat. In Zig, if I have a pointer to something, how do I return it or no? I'm having issues with this one. Let's see if it can help. If condition like this, really? I'm going to the right length. Okay. So this dereferences it. And then gets a non-null value from the optional. Oh, I guess, yeah. And we just get the address from it. I don't like this. I do not like this at all. This is so, I mean, I get that if I use Zig all the time, that I would see this and know exactly what's happening. Like this is an arrow pointer and this, and it goes or unreachable, right? Anyways, what are we doing here? Function cannot return an error. trip error like this, right? Okay, so that's it. That worked. Now I'm still not entirely sure. Entry dot slash. Because I thought that returns, that means or else unreachable. If, okay. Place. If one is not found, we return null. Oh. But I mean, like, I could have just, like, I mean, here's an optional way. The way I would have probably written this is probably to do it like return entry. I guess maybe it doesn't work that way. Okay. All right. Well, that's it. That's it for my Zig adventure today. This was a longer one. I got stuck on this one. I get how this works now because there's an if statement here. This should never be unreachable. Now, I would imagine that I would like you can probably make this an or else statement, right? I mean, you could do const thing equal entry dot or else null, right? And then return and entry thing. Does that work? No. So what, like this? No, I don't know. I don't like this syntax. I don't like it. This is the first thing I can tell you I don't like this line right here. I don't like it at all. Yeah, I don't like it. But that's it. That's it. That's all I'm doing today. See you.